Hello my friends, welcome to part 2 of this implementation where we're going to build together the artificial neural network. I'm super excited to start. We will do it in 4 steps. In the first step we will initialize the ANN as a sequence of layers. Then we will add the input layer and the first hidden layer composed of a certain number of neurons which we will choose together. Then we will add the second hidden layer, in order to build indeed a deep learning model as opposed to a shallow learning model. And then finally we will add the output layer, which will contain what we want to predict. All right, let's do this. We're going to tackle these 4 steps in this one same tutorial. So let's do this starting with this one, initializing the ANN as a sequence of layers. So let's create a new code cell. And now let me explain how we need to proceed. So the first thing we have to do is obviously to create a variable that will be nothing else than the artificial neural network itself. And guess what? This artificial neural network variable will be created as an object of a certain class. And that certain class is the sequential class, which allows exactly to build an artificial neural network but as a sequence of layers, as opposed to a computational graph, right? You saw in the intuition lectures that an artificial neural network is actually a sequence of layers, starting from the input layer, and then successively we have the fully connected layers up to the final output layer. That's what I mean by a sequence of layers. And then the other type of neural network is indeed a computational graph, which are, neurons connected anyway, not in successive layers. And an example of this is Boltzmann machines, right? Restricted Boltzmann machines or deep Boltzmann machines are great examples of computational graph. Of course, they're not covered in this course because this is really advanced deep learning, but they are covered in our deep learning A to Z course. If you are really interested in deep learning and want to go deeper into this branch, well, I'll be happy to welcome you into the Deep Learning A to Z course. But now, let's just get the right introduction to deep learning with only fully connected neural networks. And so that's why we will create our new variable, which we're going to call ANN, and which will be nothing else than the artificial neural network we're going to build. And we will create that variable as an object of the sequential class, okay? But of course, this sequential class is not taken from nowhere. It is actually taken from the models module from the Keras library, which since TensorFlow 2.0 belongs to TensorFlow, right? Before we had TensorFlow and Keras separated, but now since the new TensorFlow, the new version of TensorFlow 2.0, well, Keras was integrated into TensorFlow. And therefore, the way to call the sequential class here is to call first TensorFlow, which has a shortcut TF, from which we're going to call the Keras library, and from which we're going to call the models module. Perfect. And from which we call indeed that sequential class. And so that, all this, creates this ANN variable, which represents our artificial neural network, created as an instance of that sequential class, which initializes our artificial neural network as a sequence of layers. And that's our first step. Congratulations, now you really made your step into how to build an artificial neural network. So let's move on to the next step, which is to add the input layer and the first hidden layer. And that's where we're gonna start using the famous dense class in TensorFlow and even in PyTorch, which is another great library to build neural networks. The way to add a fully connected layer into an artificial neural network at whatever phase you are, whatever the state of your artificial neural network is, well, is to use the dense class. And the way we use it is very simply by taking our artificial neural network object, that instance of the sequential class, from which we're going to call one of the methods of the sequential class, and that method is add. We certainly hope that there is an add method inside a sequential class, right? So that's the method we need right now to add anything we want, whether it is a hidden layer or a dropout layer, which allows to prevent overfitting. Or, we will see with convolutional neural networks that we can also add, well, a conv2D layer, which is a convolutional layer. Well, we can add anything, but right now what we want to add is a simple fully connected layer. And the way to add this is to enter in these parentheses, because add is a method. Well, it is to add exactly that fully connected layer, which will be a new object, it will be a new instance of a new class. And that new class is, of course, the dense class. So the fully connected layer we're about to build will be created as an object of the dense class. And therefore, now the only thing we have to do is to call that dense class. And this will create that fully connected layer object. And at the same time, it will automatically add the input layer. All right, so let's call that dense class. And once again, that dense class is not taken from nowhere. It belongs to a certain path of libraries. And of course, the root of that library is our TensorFlow library, then from which we're going to call, once again, the Keras library. There we go. From which, this time, we're not going to call the models module, but actually this one. You know, it's top of the list, layers. That's exactly what we need to add here. This is the module that contains the different tools, and by tools I mean classes, to add, well, any layer you want in your artificial neural network. So layers here. And speaking of these classes, well, that's from this layers module that we're going to call our dense class, which, as any class, can take several arguments. And here we have to indeed enter these arguments. The most important one is this one, unit, which corresponds exactly to the number of neurons, you know, to the number of hidden neurons you want to have in this first hidden layer. You know, not in the input layer, we will automatically have our different features. You know, in the input layer, the input neurons will simply be all these features starting from credit scores. That will be one neuron, then another input neuron, then another one, you know, up to this one. All these will be the input neurons in the input layer. But then, when we create that first hidden layer, we will have some hidden neurons inside. And in this dense function now, well, we can specify, of course, how many hidden neurons we want to have. And now comes the most frequently asked question in deep learning, that very famous question: how do we know how many neurons we want? Is there a rule of thumb, or should we just experiment? Well, unfortunately, there is no rule of thumb. It is just based on experimentation, or, you know, we call it the work of an artist. You have to experiment with different hyperparameters. You know, we call them hyperparameters in the sense that these are parameters that won't be trained during the training process. So unfortunately, there is no rule of thumb, and therefore we just have to pick one number here, which wouldn't sound irrelevant or extravagant, and that number will be 6. I actually tried several numbers and I got more or less the same accuracy in the end, so it's all good. You can try different ones if you want, but 6 is totally fine. So here inside this dense class, we will enter for our first parameter, which is unit. Well, units equals 6. Perfect. All right, and now the next parameter that is important, you know, among this huge list of parameters, you can see many of them, but no worries, we will keep the default value for all of them except this one, which corresponds, of course, to the activation function. And you saw in the intuition lectures with Kirill that the activation function in the hidden layers of a fully connected neural network must be the rectifier activation function. And therefore, that's exactly what we must specify here. We, of course, don't want no activation function. So here we have to specify that we want the rectifier activation function. And the way to specify this is to enter here in our activation parameter, well, the code name for the rectifier activation function, which is, in quotes, well, ReLU. That's the code name for the rectifier activation function, and that is all you have to enter here in order to make a fully working, first fully connected hidden layer. Congratulations! Now you know how to build actually, you know, a shallow neural network, and you will know in a second how to build a deep neural network, because the way to actually add a second hidden layer here couldn't be more simple. The only thing that you have to do is just copy this line of code, and then in a new line of code here for the second hidden layer, you just need to paste it. That's what I mean by this add method can add any new layer at whatever stage of the construction process of your ANN you're into, right? You can use this add method to add anything, and the way to add a second hidden layer is just the same as adding the first hidden layer. Unless, of course, you know, you want to change the number of hidden neurons, but, you know, 6 hidden neurons in the first hidden layer and 6 other ones in the second hidden layer is just fine. But once again, feel free to change the hyperparameter values here. Maybe you will get a better accuracy in the end. And if that's the case, well, please share it in the comments or by private message. Okay. However, now to add the output layer, you have to do something special, you know, something different than what we did here. So let's do this together. Let's create a new code cell. And, well, let's actually paste what we just copied before once again here. But this time we'll have to change two things, which correspond actually to the values of these two parameters. But first, let me explain why all the rest is the same. Well, that's of course because, we're adding a new layer, and this add method can add any layer you want, including of course the output layer. So here we're still using the add method to add this final output layer. And then of course we still want our output layer to be fully connected to that second hidden layer, and therefore we're using again here the dense class. So all good here, but then these two parameters have to be changed. And if you followed the intuition lectures, you should know what must be these two changes. All right, so let's start with this one. According to you, what do we need to replace here? Well, that's of course this value, but according to you, 6 has to be replaced by which value? Well, to get the answer, we need to have a look at our dependent variable again, which is this one, because remember, the output layer contains the dimensions of the output, the output you want to predict. And here, since we actually want to predict a binary variable, which can take the value 1 or 0, well, the dimension is actually 1, right? Because we only need one neuron to get that final prediction, 0 or 1. However, if we were doing classification with a non-binary dependent variable, like a dependent variable that has 3 classes, let's say A, B, C, well, we would actually need 3 dimensions, 3 output neurons to once again one-hot encode that dependent variable. Because of course, once again, there is no relationship order between the classes A, B, and C. So A, for example, would have to be encoded by 1, 0, 0, then B would have to be encoded by 0, 1, 0, and C would have to be encoded by 0, 0, 1. And therefore you need 3 neurons getting these values 0 and 1 to encode your 3 classes A, B, and C. But here, since we actually have a binary variable, a binary outcome, well, you only need 1 neuron to encode these outcomes into 1 or 0. And therefore, the value of that unit parameter here that we have to replace right now is actually 1. Okay? 1 output neuron encoding the dependent variable. And then, second change corresponds of course to that activation function, and more specifically to the value of the activation function. Well, once again, remember in the intuition lectures that for the activation function of the output layer, well, you don't want to have a rectifier activation function, but a sigmoid activation function. Why is that? It's because having a sigmoid activation function allows to get not only ultimately the predictions, but even better, it will give you the probabilities that the binary outcome is 1. So that we will not only get the predictions of whether the customers choose to leave or not the bank, but we will also have for each customer the probability that the customer leaves the bank. And all this thanks to that sigmoid activation function. So you definitely want that sigmoid activation function for the output layer only. All the other layers, the other fully connected layers will get indeed that rectifier activation function. And now I really must say congratulations, because we're actually done with the creation of this very first artificial neural network, so you can be proud of yourself. You just built an artificial brain. Was that hard? Was that overwhelming? I don't think so, and that is the beauty of TensorFlow 2.0. So I hope you enjoyed this. I hope you enjoyed building your very first artificial brain, but that's not over now. We only have a brain so far, but which is totally stupid actually, because it was not trained yet on the dataset. So we're going to make it smart, and we're going to make it smart in part 3, training the ANN, in which we will first compile the ANN with, an optimizer and then a loss function, and then we will train finally our artificial neural network on the whole training set in a certain number of epochs, and you will see that the training process will be very exciting to visualize. I can't wait to show this to you. Let's tackle part 3 together in the next tutorial, and until then, enjoy machine learning.